In this video, we will understand why Helm charts are required. We'll see what are the set of problems that this solution is trying to address. So to start with, as we know, whenever we want to run an application on Kubernetes cluster, first thing we have or we need to have is its image, container image, right? So to run this container image on Kubernetes cluster, we create this set of Kubernetes objects, like some of them which I mentioned here. So to create these Kubernetes objects on cluster, we mainly use these two approaches, imperative and declarative approaches. Okay. In imperative, we use this kubectl client tool to directly write the commands on CLI to create these objects on the cluster. In this approach, the main disadvantage is we cannot keep track of like who created these objects and what was the initial configuration and so on. In declarative approach, we define the complete configuration using YAML manifest files, and we store these manifest files in Git repositories. In this approach, we can easily keep track of all the changes, and we can keep track of the configurations as well. Like if you see here, we define like what object needs to be created, how many replicas, and what image it should use. So the complete configuration can be easily tracked using this approach. Now in this approach, in imperative approach, when we run this command, it directly creates this object onto the cluster. But in here, so whenever we define this manifest file, and if we want to provision this object on the cluster, we need to run this kubectl apply command to apply the changes of this manifest file. Okay. And as we were discussing, like to deploy a single application, we have or we need to define or declare these different type of Kubernetes objects. So for each and every Kubernetes object, we define these set of, when we use this approach, we define these set of different manifest files. Okay, for example, for deployment we'll have one, for namespace we'll have one ingress, HPA, job, and so on. So now the difficult part over here is, if I want to apply all these manifest files to the cluster, then I need to run this command for each and every file. Okay. Let's say this is still acceptable if the application is simple and we hardly do changes to these manifest files. But let's say if the application is huge and if we keep on changing these manifest files, then it is not an easy way to apply the changes, deploy the application, these manifest files, right? So this is a kind of one broader problem, but we'll understand some more problems which we have if we do not use Helm charts. For example, I have listed some of them here. We'll move this aside for a little bit. Now here I mentioned the problems are like no easy deployment, right? We discussed it. It's very hard to apply or deploy these manifest files if it keep on changing or growing. And hard-coded values. If you see this manifest file, here we have hard-coded replicas, image, version, right, and so on. If we want to deploy this same manifest file to different environments, we cannot have these hard-coded values, right? And manually track dependencies while deployment. For example, now here we are talking about front-end image. Now let's say I have this back-end one, okay, or you can say database Docker image. So now how do we keep track of these dependencies? We want to have this front end only when the backend database is already this application is already running. So if the database is there, then we want to deploy this front end, then it's tough to track that, right? And cannot maintain versions. So since we are deploying them individually, we cannot keep track of like which version of the manifest file we have in our cluster and what version of our application is running on the cluster. And tough to remove objects. So since these objects will be interlinked, then we need to manually check those dependencies and remove them carefully. If not, the complete application will break. And not easy way to share with others. So now with these like hard-coded values without much knowledge of dependencies and without version control system, then if we share these files, then we need to explain them all these things to the dependent team, right? So not so easy to share with others, and cannot reuse part of this code snippet also, right? So if we have like, if we want to use this part of the code in other manifest files, then we cannot do that. So these are like set of problems which we come across if we do not use Helm charts. So Helm charts basically helps us in solving most of the problems which we discussed here. So the first thing what it helps us in is creating the package of our manifest files. Okay, so now since we are deploying them, applying the changes like one by one, we can create a package of this complete files and apply them in one go. Okay, and create templates to avoid hard coding. So here we have hard coded these replicas and image tag, image name, right? But we can parameterize them and pass as an argument from values.yml file. So we can create this complete file as a template, and we can avoid hard coding. We can use hooks to define pre and post dependencies also. Let's say if we have some job which needs to be run faster, then we can use pre and post hooks to achieve that. And in the chart also, let's say if we have different chart for database and different chart Helm chart for front end, then we can define the dependency of database chart in front end. If we do that, then this Helm chart will install this Helm chart first, and then it will install the front end. And we can keep versions through its releases. So whenever we install Helm chart on our Kubernetes cluster, it creates a release of that. So whenever, like, the number of times we install the same Helm chart, it creates those many releases. So with the help of releases, we can easily keep track of like which release is currently running on the cluster, and through that release version we can roll back and we can uninstall particular release. We can do all these actions. And not easy way to share with others here, but here we can easily share. So we can, since we are creating this package, we can store this package on HTTP repositories like GitHub pages, on Azure Storage, Artifact Hub, and so on. So we can store this package in those repositories and share that URL to other team members, so that they can simply get that package and install in wherever, like in their clusters easily. And cannot reuse part of the code snippet. Here we can define name. We can use name templates to define reusable code snippet. For example, this labels, if we want to use in multiple places, then using name template we can define this part of the code in the name templates, and we can use that as a reference in our multiple manifest files. So these are the set of core problems, and the Helm chart is trying to solve. Now what we'll do is I'll keep it up to here, and in coming videos we'll explore all these options one by one. So thank you for your time. See you in next video.